This is day 10 of Unit 9, or the first day of Part B of Unit 9. So we started today with this warm-up. Take a moment, pause, and try it, and then play to check your answers. So if I'm flipping 3 coins, I have to start with the first coin, and I have heads or tails. And then second coin, heads or tails. And then the third coin, heads or tails. Quick diagram there, kind of messy, but you get the idea. Okay, so we count those. We have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes in the sample space. Okay, then we talked about how in the second half of this unit, we're going to be basically taking this diagram, this tree diagram, and condensing it. Because the more coins we add, the more complicated the tree diagram is going to get. And so there has to be a way to make that less complicated. And that's by making what we call a decision chart. So a decision chart is you start by, again, just like we did with the tree diagram, deciding what the definites are, or what are the events. In this case, the 3 coins are the events. So there are 3 events, 3 coins. So I make a decision chart by making 3 blanks. So the blanks represent the number of events. Then each blank represents each event. And on that blank, I'm going to put the number of choices. So my first event is the first coin. My choices are heads or tails. That makes 2. Same thing again, the second coin, 2 choices, and again, 2 choices for the third coin. I multiply those in a decision chart always, and 2 times 2 times 2 is 8. Okay, so that way I was able to condense that diagram, not even have to make the diagram, and instead make a decision chart. So that's what we're going to talk about today. Okay, so first thing I want to do, you want to copy this in your notes. So I'm forming words out of these letters. How many arrangements of the letters are possible? Well, again, there are 4 events, so 4 blanks. How many choices for the first letter? 4. I'm arranging these letters, so I can't, we're talking about Scrabble, so I can't repeat the letters because I don't have tiles with that many letters. I don't have A more than 1 time. So if I can't repeat the letters, then this is 3, and then 2, and then 1, and I multiply, and I get 24. So that's the first part. Second part asks what's the probability of making a word using the 4 letters. So words, we have to think of all the words we can make with those letters. So span, naps, hands, and snap. I think there are 4 letters out of 24 total arrangements, which makes a probability of 1/6. Okay, so you'll see in this second half of the unit, we'll start to combine what we learned about probability in the first half with some new ideas here like decision charts. Okay, next example, copy that into your notes. So this time I have 4-digit numbers that I'm making using digits 1 through 7, and it's okay to repeat a digit. So first of all, 4 blanks because of the 4 digits. Those are my events. 7 choices because numbers 1 through 7, I'm allowed to repeat. So once I've chosen 1, let's say for the first digit, I can use 1 again. So 7, and again, and again. I multiply those, and I get 7 to the 4th, which is 2,401. Okay. This time, we're not allowed to repeat digits. So still 4 decisions, 4 events. Still 7 choices for the first one, but then I can't repeat. So that's going to be a 6 and a 5 and a 4. And I'm going to multiply. And when I do that, I get 840. Okay. So Marcos is selecting classes. He plans to take English, physics, government, pre-calc, Spanish, and journalism. How many ways might the school arrange his day? Well, so you want to copy that in your notes, but first of all, we really just care about the fact that there are 1, 2, 3, 4, 5, 6 classes. So I'm going to go ahead and make 6 blanks. and I'm thinking about how many choices for the first blank. The first blank represents first period, so there's 6 choices. Now, even though he might really, really want to take pre-calculus 2 periods in a row because he just loves pre-calc, um, he can't. He can only take it one time, one period. So that means 5 classes are left, and then 4, and then 3, and then 2, and 1. And we multiply that, and when we multiply that, we get 720. Okay. Now, that's one way to do the problem, using a decision chart and 6 times 5 times 4 times 3 times 2 times 1. Now, some of you may have learned previously in other classes about what's called a factorial. The factorial symbol looks like an exclamation point, but in math class, it doesn't mean that you're excited or showing enthusiasm about something. It means something different. In math class, when I have a number 6, in this case, followed by the factorial symbol, that means I'm going to start with that number 6 times 1 less, times 1 less, continue to multiply by 1 less until you get down to the number 1. So 6 factorial is the same thing as 6 times 5 times 4 times 3 times 2 times 1, and 6 factorial is equal to 720. Now, I did explain in class how to type that in the calculator. So go ahead and just see me outside of class if you don't know how to type that in the calculator. Okay, let's try the next one. How many possible ways are there to arrange the letters M, A, T, and H? So think about that. 4 definites, 4, 3, 2, 1, or 4 factorial. So that equals 24. Next, how many batting orders can be made from 9 starting players on a baseball team? Well, I am realizing that once a certain player plays, like goes first, they're not going to play again. They're not going to play second. So that means that we have 9 and then 8 and then 7, 6, 5, 4, 3, 2, 1. So that's 9 factorial. And 9 factorial is equal to what? 362,880. Okay, next. So let's try these. Now, I explained in class that I want you to show work for simplifying these. I don't want you just to type 9 factorial divided by 6 factorial in your calculator. So let's talk about how we would do that. Well, 9 factorial means 9 times 8 times 7 times 6, and we'll keep going, times 5 times 4 times 3 times 2 times 1. Now, I'm not going to write times 5 times 4 times 3 times 2 times 1, because first of all, I don't feel like writing all that out. But secondly, I'm noticing that in the denominator, I have 6 times 5 times 4 times 3 times 2 times 1. I have 6 factorial. Well, I have 6 times 5 times 4 times 3 times 2 times 1 in the numerator. So instead of writing that out, I'm just going to write 6 factorial. So I got down to 6, but then 6 factorial is in both the numerator and the denominator. So rather than writing it out, I'm just going to leave it as 6 factorial. Now, the reason that's helpful is because now I have a common factor here that I can factor out. When we factor out, we're left with 1s. So now I can very easily simplify 9 factorial divided by 6 factorial into 9 times 8 times 7, and then multiply that out. 9 times 8 times 7 is 504. So that's how I want you to do those. So let's try this one. 20 factorial divided by 18 factorial times 2 factorial. First of all, just make a note in your notes that 18 factorial times 2 factorial is not equal to 36 factorial. Okay, you can't do that. You can't multiply the numbers. That would give you a completely different value than 18 factorial times 2 factorial. And if you're not sure, try it out. You can very easily see that they are not equal. So I can't do that, but what I can do is start writing out 20 factorial the way I did the last problem. 20 times 19 times 18. I'm going to keep going until I'm noticing, oh, I've gotten to the same number that I have in the denominator. So rather than writing times 17 times 16 times 15, I'm just going to write factorial following the 18. So I have 18 factorial, and then 2 factorial is 2 times 1. So the 18 factorials factor out, and I'm left with 20 times 19 divided by 2 times 1, which is just 2. And let's see, 20 divided by 2 is 10. 10 times 19 is 190. Okay. Next, we're going to do the same type of problem, but with variables instead. So really the approach is the same. You just want to keep in mind what factorial means. It means that number times 1 less, times 1 less, times 1 less until you get to 1. So having said that, I'm going to start with that number, n, times 1 less, which would be n minus 1, times 1 less, which would be n minus 2, and I'm going to continue until I get to 1. But I'm noticing again, n minus 2 is in the denominator, so rather than writing n minus 2 and then n minus 3 and so forth, I'm just going to write n minus 2 factorial, and in the denominator as well. Now I see common factors. I'm left with n times the quantity n minus 1, or if you want to distribute that, you can. Either would be fine. I don't care if you leave it in factored form or distribute it. Either's fine. What we do need, though, included as well, that's a comma, is hopefully you remember earlier in the year when we simplified expressions with rational expressions where there was a variable in the denominator, we always included a domain restriction. So we'll do that again. So if you recall at the time, the way that we did a domain restriction, remember when we didn't have this factorial there. So just looking at n minus 2 in the denominator. Remember, we set that not equal to 0 and we solved and we got n is not equal to 2. So I'm going to do this kind of the same way. I'm going to pretend the factorial is not there and I'm getting the value of 2. 2's what we would write is the restriction, n cannot equal 2. But instead of being cannot equal to, here, because it's a factorial, we actually can have 0 factorial. If you type 0 factorial in your calculator, you see that it equals 1. So I'm allowed to have 0 factorial. So rather than not being 2, it actually can equal 2 because 2 minus 2 would be 0 factorial, which is 1. So that's okay, then I'm not dividing by 0. So that means that n can equal 2, or it could even be bigger, because if it was 3, 3 minus 2 is 1, 1 factorial, I'm not left with 0 in the denominator. So we're going to say n is greater than or equal to 2. That's my restriction. Okay, so again, just treat it like the factorial is not there, like we've been doing all year. That would be n is not equal to 2. But instead of writing the not equal symbol, it's going to be greater than or equal to that number. So in this case, 2. Next one, starting it off, n plus 2 factorial. So that means n plus 2. Now, remember, the definition of factorial is that number times 1 less, until you get down to 1. So 1 less than plus 2 is going to be plus 1. And 1 less than plus 1 is n. And now I'm seeing I have that in the denominator. So I'm just going to leave the factorial there. Cross off the common factors. I'm left with quantity n plus 2 times the quantity n plus 1. And again, you can leave that or multiply it out. I'm just going to leave it. Either's fine. And then I need my restriction. So I'm going back to the original denominator and I'm seeing n factorial, which means normally we'd say can equal 0. So we're going to say greater than or equal to 0. Okay. Lastly, write in factorial form. So we have 7 times 6 times 5 times 4. Now, I just want to make sure you understand what that's asking. Let me go back 2 questions. So here, 9 factorial over 6 factorial, that is factorial form. That's simplified to 9 times 8 times 7 because the 6 factorial is factored out. So if I had started with 9 times 8 times 7 and said put it in factorial form, I would be writing 9 factorial over 6 factorial as my answer. Okay, so that's what we're doing. We're going in the reverse order. So we want 7 times 6 times 5 times 4 to be the final answer. So we know that we're going to have a 7 factorial. And now you just have to figure out what needs to go in the denominator. Well, remember, whatever crosses off or is in common, I have to be left with a 7, a 6, a 5, and a 4. Meaning that what has to cross off would be the rest of 7 factorial, which is going to be 3 factorial. Right? Because the 3 times 2 times 1 has to cross off so that we're left with 7, 6, 5, 4. Okay? That is our answer for factorial form. So go ahead and try this one. 10 times 9 times 45 times 44. So I'm going to make one big fraction here. So same as I did with the 7 factorial over 3 factorial to get 7 times 6, we're going to do that to get 10 times 9. So hopefully you're realizing that's 10 factorial over 8 factorial. The 8 factorials will cross off and we'll be left with 10 times 9. Do the same thing with the 45 and the 44. So 45 factorial And notice I'm just putting that right beside the 10 factorial. I'm not making two separate fractions. Hopefully you're realizing that should be a 43 factorial. The 43 down to 1 will cross off, and I'll be left with 45 and 44, and that is my final answer. That is factorial form. Okay, homework for tomorrow, pages 1 and 2 in your new packet, and page 23, problems 17 to 20. Do those for tomorrow.